Okay, so we saw the three ways of evaluating limits, and most importantly, we learned about the direct substitution property. So that says that when we are finding limits, as long as the function is a polynomial or a rational function, we can simply plug in the value that x approaches into the function. So to evaluate this limit, we can simply just plug in 3 over here in place of x plus 9 divided by 3. So that gives you 9 plus 9, 18 over 3, and this becomes 6. So therefore, the limit is equal to 6. Another example here, so I'll just plug in 5 wherever I have an x. 5 squared minus 3 multiplied by 5 plus 5 divided by 2 times 5. So this is 25 minus 15 plus 5 divided by 10. So that basically gives us. So now using the same approach, let's try and solve this question. So x is approaching 5, so I'm just going to plug in 5 everywhere. So this is 5 over 5 minus 5 squared minus 25. So this is giving me a 0 over 0. Now is 0 over 0 equal to 0? No. 0 over 0, it mathematically is a special form that's known as an indeterminate form. And 0 over 0 is not the only indeterminate form. There is a total of 4 indeterminate forms. So 0 over 0, when you have plus or minus infinity divided by plus or minus infinity, when you have infinity multiplied by 0, and when you have infinity minus. So these are the 4 indeterminate forms. So what exactly do we do when our answer is an indeterminate form like it is over here? So this is where algebra comes into place. So there are several techniques that we can use to modify this function, right? While keeping it mathematically equivalent, but getting rid of the indeterminate form. So the first one is what we call factoring. So if we look a little closer, the denominator is x squared minus 25. Now this is what we call a difference of two squares, because we can write x squared minus 25 as x squared minus 5 squared. And this can be written as x minus 5 multiplied by x plus 5. The definition of the difference of two squares is a squared minus b squared is mathematically equal to a plus b multiplied by a minus b. So if we write x squared minus 25, or if we write x minus 5 multiplied by x plus 5, mathematically it's the same thing. We're just modifying it. So using this, let's rewrite our original function. So we have the limit as x approaches 5, x minus 5 divided by, now instead of writing x squared minus 25, I'm going to write it as x minus 5 multiplied by x plus 5. Now this and this will cancel. And now what I'm going to remain with is the limit as x approaches 5 of 1 over x plus 5. I cannot factor this further, so that gives me no other option but to plug in. So now if I plug in the value of x, I'm going to have 1 over 5 plus 5, and the final answer is 1 over 10. So this is the definitive answer. And therefore, it's safe to conclude that the limit as x approaches 5 of our function over here is equal to 1 over 10. Okay, so let's try and solve this other question. So as usual, the first thing is that we're going to try and plug in. So this is minus 3 squared minus 9 divided by 3 plus minus 3. So minus 3 multiplied by itself is positive 9. So that gives me 9 minus 9 divided by 3 minus 3. So this basically is 0 over 0. And we just said that this is an indeterminate form. So now what we're going to do is we're going to use some sort of algebra to modify the function in order to not get an indeterminate answer. So again, if we look closely, in this case, the numerator is the difference of two squares because I can write x squared minus 9 as x squared minus 3 squared, and this can be written as x plus 3, x minus 3, just using the difference of two squares. So now I can rewrite the original function. The limit as x approaches minus 3 of x plus 3 multiplied by x minus 3 divided by 3 plus x. So we can cancel this, and what we're going to remain with is the limit as x approaches minus 3 of x minus 3. And now I'll just plug in. So I have minus 3, which is equal to minus 6. So therefore, our limit as x approaches minus 3 of the function is equal to minus 6. So now let's try this other question. So I'm going to plug in first. So this is going to give me 5 squared, that's 25, minus 5 minus 20, divided by 5 minus 5. And this is going to give me 0 over 0, which of course is indeterminate. So what can I do over here? We know that the numerator is x squared minus x minus 20. Now I can factor this polynomial, right? So our sum in this case is going to be this number over here. So what is the coefficient of the x? It's a -1, right? And our product in this case is going to be this multiplied by the coefficient of the x squared. So it's just going to be 1 times -20, which is -20. So now I need two numbers that add up to give me -1 and that multiply to give me -20. So I can think of 4 and -5. So when I do 4 plus -5, I'm going to get -1, which is our sum over here. And at the same time, when I do 4 multiplied by -5, I'm going to get -20, which is our product over here. So therefore, our two numbers are 4 and -5. So now I'm going to rewrite this as x squared plus 4x minus 5x minus 20. The order in which I write the 4 and -5 doesn't really matter. You could have written the -5 before the +4. Now if I go and factor this, I can rewrite this as x plus 4, and over here I'm going to write the same x plus 4, and over here I'm going to have a -5. So therefore we can factor the polynomial into x plus 4 multiplied by x minus 5. So now let's rewrite the original function. So we can rewrite this as limit as x approaches 5 of x plus 4 multiplied by x minus 5 divided by x minus 5. So this will cancel out, and that leaves us with the limit as x approaches 5 of x plus 4. And now if we plug in, so we're going to get 5 plus 4, and therefore the limit is 9. So therefore we can say that the limit as x approaches 5 of our function is equal to 9. Let's try and solve this other example. So we're going to plug in first. So we're going to have 2 multiplied by -3 square plus 7 times -3 plus 3. So this is 18 plus -21 plus 3, and that basically gives us 0. So in this case, 0 by itself is not an indeterminate form, right? So that's it. The limit as x approaches -3 of our function is equal to 0. No problem at all. Remember that 0 by itself is fine, but 0 over 0 is the indeterminate form. Okay, so let's go ahead and solve this. So first things first, I'm going to plug in as usual. So 3 minus 3 square divided by 3 square, 9 minus 9. So this is giving me 0 over 0, which as we know is indeterminate. So we can see that the denominator over here is the difference of two squares. So I can write the x square minus 9 as x square minus 3 square, which can be written as x plus 3 multiplied by x minus 3. So I'm going to rewrite the original function as the limit as x approaches 3 of x minus 3 square divided by x plus 3 x minus 3. Okay, so when I say x minus 3 square, so this is basically the same thing as x minus 3 times itself. So x minus 3 multiplied by x minus 3. So I can rewrite the top part as x minus 3 multiplied by itself divided by x plus 3 times x minus 3. So we're going to cancel this, and that basically leaves us with x minus 3 divided by x plus 3. And now if I plug in, I'm going to have 3 minus 3 divided by 3 plus 3, which is 0 over 6, and this is equal to 0. 0 by itself is not indeterminate. So therefore we can say that the limit is equal to 0. Okay, so let's go ahead and solve this final question for this video. So we're going to plug in first. So this is going to be minus 3 cubed plus 27 divided by minus 3 plus 3. So minus 3 times minus 3 times minus 3 is minus 27 plus 27 divided by 0. So this is going to give me 0 over 0, and that's indeterminate. So can we factor in this case? Might not seem obvious, but the numerator is x cubed plus 27. And what can we write the 27 as? We can express it as x cubed plus 3 cubed. So now what we can do here is we can use the sum of two cubes. So remember this, we say that when we have cubes, right? So the difference of two cubes, a cubed minus b cubed, can be rewritten as a minus b multiplied by a square plus ab plus b squared. And the sum of cubes can be written as a plus b multiplied by a square minus ab plus b square. These are like important formulas. It might take some time, but you really need to remember them. So in our case, we have the sum of two cubes. So we're going to use this formula. So I'm going to rewrite the x cube plus 3 cube using this formula over here. So I can set my a equals to x and my b equals to 3. So wherever I have a over here, I'm going to write x instead of it. And where I have a b, I'm going to write 3. So this can be written as x plus 3 multiplied by x squared minus 3x plus 3 squared, which is 9. So I can just write that as x plus 3 times x squared minus 3x plus 9. So now let's rewrite the original function. So the original function can be rewritten as the limit as x approaches minus 3 of x plus 3 multiplied by x squared minus 3x plus 9 divided by x plus 3. So this and this will cancel out, and now we're left with the limit as x approaches minus 3 x squared minus 3x plus 9. And if we plug in now, so this is minus 3 squared, and minus 3 times minus 3 is plus 9, so that basically gives us 27. So therefore we can say that the limit is equal to 27.